Modernizer is an application which might be used in projects where AI-assisted modernization and code generation are important parts of the software development lifecycle. In Modernizer, we can load various code bases in different programming languages, and we can create quick application description. We can generate documentation, insights, security and technical depth analysis, and we can also perform multiple experiments. Let me show you some of the most interesting features of Modernizer. First of all, this is the initial dashboard of Modernizer. We can create a project, and essentially we can load the project code base from a folder or from a GitHub repository or from a zip file. Once this code base is loaded, we can enter into that project and we can see quickly the technology, framework, legacy status, and a project description. Of course, we can also see some statistics, so we know what is the technology focus on this in this given project, and we can perform quickly a discovery. For instance, I would like to know what this file is doing and what is the logics used in that file, and this logics is automatically analyzed for us. So we can see what is the structure of that file. It allows to quickly enter even the most legacy code bases. We can also see the analysis of the system design, so we can analyze quickly what are the good and bad parts of that given project. We can also see the folder descriptions, because it's sometimes important to know in the given code base what the specific folders contain. Some of them might contain the business logics, some of them might contain, for instance, infrastructure as code, or other parts not directly connected to the application. So we can see that this classes is essentially a business logic folder, and the other folder contains, for instance, tests, so it's quickly described here. We can also perform so-called interactive discovery. So in other words, if we would like to ask some freestyle questions to the code base, we can use this part. And I have created one of these questions. This is how does the login process works, and I ran it before because it takes some time, like 1 up to 2 minutes depending on the size of the repository. And the agent which works behind the scenes found an answer to that question, and it analyzed all the files that are probably involved in the login process and described it step by step and described its technical grounds. We can also perform so-called deep analysis. So if we would like to analyze the process and analyze the code base more, which of course will take additional time, we can enter insights, and we can create an insight on a given folder or even on the whole code base, but typically it's done on a given folder or a given subfolder. So for instance, we've made here an analysis, a deep insight on the folder classes, which contains the business logic, and there is a detailed description of every class here, as you might see. There is also a summary of the technology stack, and also I can enter the structure analysis, where I can click a class and see what are the details of this class, what is the potential technical debt in that class, what are the internal dependencies and external dependencies, and what is the basic flow of that class, so what is actually happening inside. From the same perspective, I can do a technical debt analysis. So for instance, I've made a technical debt of the folder classes here. It's of course automatically generated, and I see that there are some weaknesses here which we should handle. I can enter a specific class, for instance dashboard, which contains some additional information which at the end of the day might be automatically changed into some Jira issues to handle. I can also create a report which will contain all the findings in a well-formatted document. The same thing applies to OWASP Top 10 analysis, so I can create an OWASP Top 10 security analysis, and of course if I did that on the classes folder. I can see the summary and the details of the analysis. And of course, additionally, it also can create a high-level plan and the estimation for solving these issues, of course, based on the severity of these issues. So the order of things to do are based on the severity. I can also try to create code requirements, business requirements from the code base. Typically, these business requirements might be done from a single file, but also from multiple files. And this is in a well-known format of the features and requirements internally. So if I would like to make a reverse engineering of a given code base or a given part of the code base, I can do it quickly here. If I would like to rewrite the application from scratch, this might help to define what actually has to be rewritten, and it will help to streamline your work on the application of the application modernization or even of the application re-architecture. And one of the most important parts of Modernizer is field for experiments. And we have here a lot of different types of experiments. For instance, we can do an advanced modernization. So for instance, we have a code base in PHP, and I would like to select a couple of files and create a plan for these selected items. So what to do to modernize? The thing is with advanced modernization that the agent behind the scenes tries to keep the technology. So it will create a plan for PHP specifically. If we would like to change the technology, we can select again a couple of files, and we can say that my persona is a skilled Symfony.NET experienced developer. I would like to migrate it to .NET 8, and I can append on also some additional rules, which will then be reflected in the performed modernization experiment. One of the most effective way or efficient way of doing this kind of modernization is a so-called pattern-based modernization. So again, if I select this file and I would like to use the same persona, I would like to append the same rules, but the thing is that the most efficient way of doing this modernization is to create a pattern. So if I say that something is a legacy code and it was manually rewritten to the pattern before, I can use this as a pattern for next modernization. So if a class A was rewritten to class A1 in the new technology, then the class B should be implemented or should be rewritten in the same way or modernized in the same way as class A. Of course, this does not apply to a single class, and pretty much never the single class is an output, but this is just something that is a good example how that might work. Typically, the patterns contain multiple files as input and output. Sometimes, however, I would like to create a document-based generation, so I do not take into account the existing code. I'm just taking into account that I have some source documentation, for instance, some definition of a Swagger file or an API definition, in other words, and I would like to say this is the Swagger file of something that I would like to modernize. And I give an output pattern and I say this should be created or generated in a way that is presented in the output pattern. And then the source documentation will be used to generate new code based on the pattern. And the last option here is so-called an auto modernization, which we use quite often. It means that we take the whole code base and we say to the agent behind the scenes that I would like to migrate to this to Golang, but what exactly must be migrated? Of course, we don't usually migrate the whole code base at once, but we say please migrate only login function or migrate only post editing function or something like that. Then it takes, of course, much less time, and we can see the results and probably use these results as pattern for pattern-based modernization. Once every experiment is started, we can see the results here. So let me start the experiment. I want to migrate the code base to Java, and I say, for instance, please migrate only post-editing part of the code base, create the whole Java Spring project setup. So we are just defining what the agent has to do. And now I have an experiment 58 which is in progress. It usually takes a lot of time because again the agent has to crawl through the structure, has to find all the dependencies and make the thing working. But I can show you some kind of different examples. For instance, I wanted to migrate a single file to Golang without any additional specification, and it just edited or created the new class in Go, which does the same thing as the class in PHP. So it's one-to-one modernization. But here it was something different. So I also specified some additional rules that I would like to create the full .NET 8 setup. So it created a solution file, project file, and this is a fully working example in the .NET 8 typical project configuration, and I can of course download that part as well to see the code base and to try to run it. Some additional functions here contain also the feature to create test cases out of the code base. So if we would like to create the test cases in Gherkin which reflect the features of the given class or given classes or given parts of the code, we can create it easily here, export and use it in our testing packages. And one of the additional functions here is also the duplication analysis. So if the code base contains a test package, we can perform the test the duplication automatically performed by GenAI. So these are the most important and most interesting features. As we can see that the process is still in progress, it will probably take something like 10 up to 15 minutes, depends on the ability of the model of the agent to find the relevant part of the code base. The more parts will be found, the more complex and long the process will be. I haven't even analyzed where the post-editing function is, how much files does it involve to make it working. But typically these kind of applications contain a lot of internal dependencies, and we can observe the result a little bit later. Thank you very much.